Okay, today we're going to do section 6.4, which we're going to graph our sine and cosine graphs still, so it's the same general idea as what you did last time, but now we're going to start to change the graph and either stretch it or shrink it or move it to the left, right, up, down, whatever it is. You're going to do half of them today, and then we're going to do the other half next time when I get back. So 6.4 is only half of the transformations. Let's see. This right here is going to go over every single transformation you can possibly have. We are not going to do all of these today, but having your general form written down today is going to be really helpful. When we're graphing them, it can always be plus or minus. I will usually give you this, or when you write the equation and go the other way, you have to know that this plus or minus has to be there. This number in front of either sine or cosine is going to be called your amplitude, and it tells you how much your graph got stretched taller, or if it got shrunk to be shorter than the normal sine or cosine graphs. There's a number in front is still going to stretch or shrink similarly to it does in most of the graphs you guys have ever done. Inside the parentheses, you'll have this variable k next to your theta that will tell you your period with this formula right here, so that's going to be an important formula to have. The C in there is going to be a phase shift, so left or right is how that will move your graph. And then your vertical shift is added out here with a plus h. Today we are only going to do your A and K, and we're going to save the C and H for next time. Whether you have sine or cosine is going to determine the shape of your graph. So the next slide, we are just going to sketch the general shapes because it's very important to know which shape you have and where you start and things like that, because that is the main thing that you will have to fill in for me. So, going to the next slide, we're just going to give you a general sketch of each type of graph. So if it is a positive sine function, your positive sine function starts at 0, then it goes to positive 1, back to 0, down to negative 1, and back up here. So all those numbers are based on last time when we talked about them. We are going to change those numbers today, but this is what your positive sine graph should look like every single time. Yes, it goes on forever, okay, so it doesn't necessarily stop there, but it will keep repeating. But this is one period of the positive sine. If it is negative, all it's doing is flipping over your graph. It's multiplying all your values you got here by a negative 1. So now this positive 1 is going to be down here at the bottom. Your zeros don't change, but now you go to positive 1 here, and then back to 0. So if there's a negative, that's literally all it does with your graph. It flips it over. Cosine is similar, okay, but we start up here at positive 1, go to 0, go down to negative 1, come back up to 0, and then to positive 1. So if you have a positive cosine, this is what you should be graphing every single time. It should look something like this. What I mentioned last time, remember, is we're really just going to change your axes. So negative cosine starts at negative 1, goes up to 0, positive 1, and then back down. Oopsies, I missed it. Okay. But this is what they'll look like every single time you graph them. When we are graphing these functions, what you are going to do every time is determine the period for your function. You're going to determine these different intercepts and your different max and min values. So you are going to be labeling all of these for me, and your max and your min. You will always just draw this first period, and I will be checking basically what you chose for your different values there. That will show me what you knew that you were doing, as well as whether you knew it was positive sine, positive cosine, or negative cosine. Okay. These next steps, right here, go ahead and take a second to write those down. Today, like I said, we are not going to do all of them. We are just going to do half of them, but having them all written down is going to be important. Go ahead and pause this until you've had time to write them all down. This is what your problems are going to look like. Every time you do them, you are going to draw me the same exact axes and then go through the steps on the last slide. So the first thing it tells you to figure out is your midline. While we're not changing the midline today, we do have to know what the midline is. And the way you're going to tell me is by labeling this horizontal axis you draw as that midline. Okay, since we have nothing added out back, our midline's at 0. So that's how I will know that you know that your graph has not been shifted up or down, because the midline is the x-axis. Then you're going to figure out your amplitude. Your amplitude is always just your a value. You can ignore the sign. But your amplitude is 3, so your maximum value is 3. Your minimum value is -3. Since we did not do any shifts or vertically, you do not technically have to use this formula with the h minus a and the h plus a. I give that to you for next time, but we are technically doing for your minimum 0, -3, and 0, +3. But again, for today, you will just know that it's this one. For your period, your formula is that it is 2 pi over k. Our k value in this problem is 2, so it is 2 pi over 2, or just pi. So my graph will repeat itself every pi instead of every 2 pi because of the shift right here, but with this 2 in front of your theta. What that means is along this axis, we are changing how we're doing it. My biggest value that I'm going to put is pi. These 3 other values should all be evenly distributed on your graph. So what we end up doing is dividing this number and cutting this all into fourths. So for example, this one is halfway, so pi over 2. This point right here should be 1/4 of the way, so pi over 4. And this point here is 3/4 of the way, so 3 pi over 4. Labeling your axes is how I will know that your period either shrunk in or was stretched out. Then we have to figure out if it is a positive sine graph or a negative sine graph. Since it is a negative right here, it is a negative sine function. So you can look back at your graphs that we drew on the last slide, and your negative sine function starts at 0, goes down to your minimum, which here is a -3, back up to 0, back up to your height, and then to 0 again. So this is the first period of the graph of our function. And that's what pretty much all of them are going to look like for you. So you'll figure out your midline, your max, and your min, figure out your period, and divide out your 4 equal increments that you have your key values there. The nice thing with cosine is it's going to work the exact same way. It is just a matter of making sure that you take everything into account while you're doing it. So my midline, still nothing's added, so y equals 0. Your max and your min, you look at your amplitude. Since there was no shift, it is literally just going to be at 2/3 and at -2/3. So our graph did shrink down because I didn't quite get to 1. And then we have to find our period. Our period is your 2 pi over k again. So my k this time is 1/3. When you flip and multiply, that means your period is 6 pi. Figuring out our increments along this axis, all the way is 6 pi, so halfway is 3 pi. 1/4 of 6 is going to give you 3 pi over 2, and then 3/4 of 6 gives you 9 pi over 2 when you simplify, but you can just do 3/4 times 6 and get that number. Then we just have to plot our points. It is a cosine graph, and it is positive, so it will be our normal cosine sketch, which means it starts at a max, goes to 0, goes to your min, back to 0, and then back up to your maximum. Remember, it's easy to remember that this kind of looks more like a C in the first period, which is how you can remember which one's sine and which one's cosine. But that is the graph of your cosine function. Go ahead and write this one down and give it a try and pause the video so that you can have a second to do it before I just keep on going. Now that you should have had a chance to try it, let's go over the correct answer so we make sure we all did it correctly. Again, today your midline is not going to shift, so it's still at 0, which means your max is just that number. This is 5 and this is -5. My period is found by doing 2 pi divided by 4/3. When you flip and multiply, this gives you 6 pi over 4, which you're going to simplify to 3 pi over 2. For finding your points then on your graph that are going to be your key change points, one full period means you go to 3 pi over 2. And then remember, you're going to cut it in half. This is 3 pi over 4. You're going to cut it, you're doing a fourth of this, which is then 3 pi over 8. and then 3/4 of my starting number. So 3/4 times 3/2 is 9 pi over 8. Those are your change points, and again, that is what I'm really checking. A lot of this right here is most of where your grades will come from. The last part comes from knowing that you are graphing a negative cosine function because of the sine and the trig function right there. Since it is negative cosine, you start down at -1, go up to 0, or sorry, your minimum, it's not -1, it's -5 here. Back up to your max, 0, and back down. And there's your graph. Okay, the main reason that I just have you change your axes, if you'll notice, this graph got really, really tall, which means it would be a very skinny graph because it's going a whole 10 units. It also got shrunk way in because the biggest it got was to 3 pi over 2. So it's only 3/4 of the way through your normal graph. So it would be shrunk in and it would be really tall, which gets really complicated to graph on just regular homework paper, which is why doing it this way, as long as you're keeping in mind this is taller and shrunken in. Okay. Go ahead and try this one again. Same thing. Feel free to pause it. Give yourself time to work on it, and then I will go through the correct answer. Your midline on this one again is at 0. Your max is at 4 and your minimum is at -4, so this graph is taller than your normal graph. You should find your period. You're doing 3/5, so when you flip and multiply that, you are going to have 5 times 2. 10 pi over 3. So my furthest point on this axis is going to be 10 pi over 3. To get half of that, it's 10 pi over 6, or 5 pi over 3. To get a fourth, you're looking at 10 pi over 12, which is 5 pi over 6. And then 3/4, you're going to get 5 pi over 2 after you simplify. So again, you're doing a fourth, a half, 3/4, and then that's your full period. Since it is a sine function and it's positive, we're going to follow our general form for our sine graph, which means you start at your 0, go up to your max, go back to your 0, go down to your min, and back up to here. Okay. Before we go on, let's see if I can get the internet to load. Oh, here we go. Okay, before we quit graphing and going into writing equations, I just want you to see some examples next to each other of these graphs. So I'm going to graph a couple of them on Desmos just to give you an idea of what these shifts are really doing now that you've graphed them on your paper a little bit. The first, I'm just going to do sine of x to give you the general parent function of your sine graph. The first one then that we graphed was y equals -3 sine of 2x. So if you notice, first off, it's flipped over from the red one. The red one goes up first and ours goes down. It also goes way higher up, okay? And that's just due to that stretch, that 3 in front. It also completes one period way before the red one does. The red one takes all the way to 2 pi to complete a period, whereas this new blue graph completes a period in half of the time, which is what we found when we did it. So our graph is way shorter. It ends at pi. It doesn't end, it keeps going, but the period ends at pi. You have a max at 3 pi over 4, which is what we had on our graph. Then here's our 0 at pi over 2, pi over 4, and back at 0, 0. So this is what your graph would look like if you graphed them together. But you can see it gets really complicated very quickly on these graphs. Let me find. So the other one that we did with sine was y equals 4 sine of 3/5 x. Oops, that means that x not in the bottom. And I don't want a g. Okay, this one we got to zoom out to see. It's still taller, just like we noticed. This time it does go to a max first, which is good because that's what we had it doing. And it takes a little longer to do a full period. Now, not a whole much longer, but it is stretched out just a little bit because of this 3/5 right here. Okay, so this is what we're really doing. Each time we have manipulated this red graph by stretching it or flipping it over and pulling it out so that it either takes longer to do a period or less time to do a period. Okay, so keep this visual in mind. You are welcome to use Desmos when you do your homework just to check yourself or to see what it's really doing as it continues on. Remember, on your graphs, I just want these important points, but the nice thing is you can check and see that, yes, we did get our important points all the way through. Okay, the last thing we're going to do is go over writing an equation. Get my computer back to ready. Okay. Again, these steps are going to go over if you have every single shift. Today we are not doing all the shifts, but you do need to have them written down just so that later you'll have all the steps anyways. Okay, so this is what your graphs are going to look like, or what your problems are going to look like when you're writing an equation. It's going to tell you what trig function it wants you to use. So as you can see here, it wants us to use sine. Today, again, your graphs are just going to be with an A and a K because that's all I've given you so far. Your 3 is your amplitude, so this is the A that we're going to use in the problem, but we have to solve to find our K like it mentions on the last slide. K is your, on this one it's actually an easier problem because it's just the denominator, but you're going to set your period, which we know is 2 pi over 3, equal to the formula it gives me, which is 2 pi over K. When you solve this, we find out that our K has to be 3. Okay, it's not always going to be that obvious, but I now have my K value. Plugging these into our general formula, the amplitude is the 3. We have the sine of 3, whoopsies, I almost wrote K, 3 theta. The only other thing you have to take into account, based on this amplitude, we don't know if it was positive or negative. We're going to write plus or minus. Okay, that is your final answer to this problem. Go ahead and write this one down and give it a try and pause the video. And when you're done, we can do it together. So looking at our information, this is my A. Here's my period. So to find K, I have to do that pi is equal, or 3 pi is equal to 2 pi over K. When you cross multiply that, your K is 2/3. Plugging this in, again, you have a cosine function, so y equals 2 cosine of 2/3 theta. Now do not forget your plus or minus because again I didn't give you any indication of if it was positive or negative, so you do have to have that for your final answer. I'll go ahead and do one more. Okay, so write this one down, pause it, and give it a try. 73 is your A. We have 7/5 pi, so why am I writing 2? I'll just use that then for my K. 2 pi over K is equal to 7 pi over 5. When you cross multiply that, your K is equal to 10/7. Again, going to plug it in, it is a cosine graph. We know it has to be plus or minus because you don't know otherwise. 73 just gets stuck in front of the problem. Then we have cosine of 10/7 theta. And that one's done. Your homework should be written on the board in the event that students forgot to write it on the board. It's going to be 6-4, number 17 through 52. Now, while you think that that's 40 problems, a lot of them, first off, it's not quite 40, and a lot of them are ones like these where you are just finding the equation given this information. Go ahead and use the rest of class time to work on your homework.